everyone, so let's solve this LeetCode hard problem. Find the count of monotonic pairs 1. So the problem states that we are given an array of positive integer nums of length n. Now we need to make means these two integer arrays AR1 and AR2 monotonic, and it should like satisfy these conditions. So AR1 should be monotonically non-decreasing, that means it should be increasing, and AR2 should be non-increasing, that means it should be in decreasing order. And we need to satisfy that AR1 of I plus AR of 2 of I should be equal to nums of I for each element. Hence we want to create these two subarrays from the given nums array such that at each index the sum of both values is equal to nums of I, and AR1 is like in increasing order and AR2 is in decreasing order. Now we need to like find out the number of ways of like making these two arrays. Okay, so we need to return the number of count of these monotonic pairs, and since like the answer can be very large, we need to return it modulo 189 plus 7. So for example, if we have the input as nums equals to 232, so the output can be, we need to make sure that AR1 plus AR2 is equals to 2. So first can be in AR1 we put 0 and in AR2 we put 2. Okay, so for 0 2 we'll have this. Now we need to make it in increasing order. In the next step we can either put 0 here and then put 3 here, but since we need to make it decreasing as well, so this is not allowed. So we'll put 1 here and then put 2 here. So this is still increasing and this is still decreasing order. So this is good. Now for the third element, we cannot put 0 here because we want increasing, so we can put 1 here, and again we can put 1 here. Okay, so this will be a valid way of like dividing into two arrays. Okay, similarly there are 4 possible ways for this 232. So, and let's see the constraints as well. So we are given that the nums length can go up to 2000 and nums of I can belongs to 50 only. Okay, so when we try to like we observe the problem statement, we know like if we try to create the subarrays, means create these two arrays, then since we want it either in the increasing order as well as for AR2 it should be decreasing order, that means if we are at a particular index I, then we should know that at index I minus 1 what element we have put, like what element we have put in AR1. So if X was the AR element we put at nums of I minus 1, then we'll for AR2 we'll be able to know that it will be simply nums of I minus 1 minus X. Okay, because the sum of 2 should be equal to nums of I minus 1. So we know like we should definitely be storing this value, the last value that we means stored in AR1. And the constraints also tells us to do the same, that since nums of I can go up to 50 only, so if we store this value, this will only take a 50 space. Okay, and 50 into like suppose 2000, so this will be 2 into 5 10, so it will be 1e5. Okay, so this will like work. So this is means we can gather a hint from here that since nums of I can go up to 50 only, hence like, and also we need the information about the last element that we might have put, we can like try creating means storing that element. Now how will we like try to calculate the result? So we obviously know like this problem will simply boil down to a DP only. Okay, how will we DP only? So we know that the indexes will be choosing and the last element will be changing. So last element is, so this will simply store that the number of ways till from 0 till index with what, with suppose we put ARR1 of index as equals to X. ARR2 of index will be simply what, nums of index minus X. Okay, so we can like maybe initialize the DP with this and then try to see the transitions. Okay, so let's try to analyze the problem statement step by step. So let's try to first analyze the formulas that we are given and then try to gradually move to a DP solution and see how we'll be calculating the result at each step. Okay, so the problem at hand is to find arrays AR1, AR2 such that ARR1 of I plus ARR2 of I equals to nums of I. ARR1 is increasing and ARR2 is decreasing. That means we need to satisfy that ARR2 of I should be equal to nums of I minus ARR1 of I. And this concludes us that if ARR1 of I is less than equals to, means it should, if we want to bring it in the form of a single variable of ARR1 of I only. Okay, because we want to choose values for ARR1 in such a manner that it is already satisfied for the second array. Okay, so we'll be choosing values for the first array in such a way that this means automatically satisfy the condition for the second array. So for the first array we need to satisfy that the value should be from 0 till nums of I, and then ARR1 of I should be greater than or equals to ARR1 of I minus 1. That means it should be in increasing order. As well as if we like try to replace for ARR2, so it must follow that ARR2 of I should be like less than or equals to ARR2 of I minus 1. Okay, that means it should be in decreasing order. So if we replace ARR2 of I with this value, so we will simply get nums of I minus ARR1 of I is less than or equals to nums of I minus 1 minus ARR1 of I minus 1. So now we have got all the formulas on the basis of a single variable only. So let's try to like restructure this formula. So we will get what ARR1 of I will be greater than or equals to ARR1 of I minus 1 plus nums of I minus nums of I minus 1. Okay, so we have got the formulas in the form of what, a single array only, and now we need to satisfy these conditions only. What are the conditions that we need to satisfy? That ARR1 of I should be greater than or equals to this, as well as it should be greater than or equals to this, and it should lie in this range. Okay, so this is what we have gathered so far. Now what can be the next step? The next step was to define the DP state. So DP state was DP of I comma x equals to number of valid ways for indices 0 till I with ARR1 of I equals to x. Okay, since we are now dealing with a single array only, and on the basis of that we'll be, since it is dependent on like the difference of nums of I and nums of I minus 1, then that will automatically ensure the values for ARR2 as well. Okay, and here x can go up to 0 to nums of I only. Okay, so we know that. So how will we like defining the DP state? So based on these two values, if we like have this, if you want to calculate this DP of Ix, then we should know like what were the range of, for this particular x, we should know like what possible values we can have in at index I minus 1. Okay, so based on this particular x, we should be able to know what values are permitted in previous index. Okay, so from this we will derive that ARR1 of I minus 1 should be less than or equals to this ARR1 of I, means ARR1 of I minus 1 should be less than or equals to x, as well as if we try to rewrite it in the form of ARR1 of I minus 1, so ARR1 of I minus 1 should be less than or equals to what? It should be less than or equals to ARR1 of I, means x minus nums of I minus nums of I minus 1. Okay, so that means ARR1 of I minus 1 should be less than or equals to both of these values. So it should be simply less than or equals to the minimum of both. Okay, so this is what we write, that ARR1 of I minus 1 should be less than or equals to minimum of x comma x minus nums of I minus nums of I minus 1. Okay, now once we have known the ranges, known the range with which we can change the element at I minus 1, then we'll be able to get we'll be able to get DP of Ix with simply what, the sum of range k equals to 0 till u, suppose DP of I minus 1 comma k. Okay, so how we'll get it? So we'll simply like DP of I comma x will be summation k equals to 0 till this u will be the range, this range. So since it is less than or equals to minimum, so that means it will be greater than or equals to 0 and less than or equals to this value. So from 0 till this value. That means it will be from 0 till this u. U will be minimum of x comma x minus nums of I minus nums of I minus. So hence we will be able to calculate this DP of Ix for by just simply taking the summation of DP of I minus 1 for these values, means from 0 till u. Okay, so now the next step is to like how do we optimize this find this sum of dp of I minus 1 from 0 till this particular value in an optimal fashion. So we know like if we try to simply iterate through like dp of I minus 1 through 50 values, so that it might go like, since for this I it will be like n, then 50, then 50. So this will be like 1e3, then we have 25 into 1e2. So this will be till 1e2. So 25 into 1e5, which will be like uh, 2.5 into 1e6. So this will also like get accepted because we like this will run means efficiently only. But we can also like know that we, since we need to find the range sum, means for this particular case we want to find the sum from 0 till a particular value. Okay, this particular value here is u, and this u will be changing for different values of x because this u is dependent on x. So if x is 0, then 1, then 2 till nums of I. Okay, so this x will vary from this range, so this u will also vary based on this x. And now if you want to efficiently find this formula, we can simply use prefix sum in the previous dp. Okay, so what we can do is we can simply like if u is less than 0, then we know that dp of ix will be 0 because there will be no valid range for dp of ix. Now to optimize using prefix sum, so we know we can use like we need to find this value. So what we can do is we can store this in the prefix of k. So it will be simply what? dp of I minus 1 0 till dp of I minus k. So we store this sum. Now we'll be able to find this value for find this value for dp of ix. We'll be able to find this value in constant time. Okay, means we'll be able to find this value in constant time for dp of ix, and hence we'll be able to like solve it into n into 50 time complexity only. This n into 50 square is also valid for the given constraints, means since the constraints can go up to 2000 only. So this is also fine, but means if the constraints are of the order of suppose 1e5, then like this 50 square into n would not have worked. Okay, so that's why this approach, means we know like prefix sum, using prefix sum in these kind of questions is like pretty easy. So whenever we want to find the range sum of till a particular index, so that's why we have tried to utilize it in our formula. Okay, so now once we have it, let's try to write the entire algorithm. So the base case that we'll have is for like index equals to 0. We know like error 1 of 0 can have all values from 0 till nums of 0, right? So hence dp of 0 comma x will be 1 for all values of x which lie in this range. Okay, so this will be the initialization of dp, that dp of 0x will be 1 for all x belongs to 0 till nums of 0. Now the next step is 2, and the final answer will be storing it. So final answer will be stored still in error 1 of n minus 1. Okay, now what are the possible ways of assigning 0 value here, assigning 1 value here, till assigning nums of n minus 1 value here. Okay, so at the n minus 1 index, what are different ways of assigning 0 then 1 till nums of n minus 1. So it will be simply stored in what, dp of n minus 1 comma x, and this x can go up to 0 till nums of n minus 1. So hence the final result will be stored in dp of n minus x, n minus 1 comma x, where x will be going from 0 till nums of n minus 1. And as this will be like the overall approach for this problem, we will be initializing the dp. Then we'll be calculating the dp using the same formula of at each step for dp of I minus, means we'll be moving I from this 0 is already initialized, so 1 till n minus 1. Then inside we'll first like compute prefix. Okay, so compute prefix till like 50, from 0 to 50. Okay, then we'll calculate move x from 0 to 50 and calculate dp of ix. Okay, using simply prefix of u will be simply what, minimum of x comma x minus num of I plus nums of I minus 1. The same formula that we had. What was the formula? The formula was x minus nums of I minus nums of I minus 1. Okay. So that stuff will do that, and then in the end we'll be simply calculating a final result by iterating through the dp of n minus 1, and for each x from 0 till nums of n minus 1. So let's see the optimized code for this solution. I hope the approach for this is pretty clear, because as soon as we observe the problem statement, we are able to see that we definitely need the information from the element that we store at previous state, and from that we try to derive, means define the dp state, and then we try to see like what are the possible means range of the previous element based on the current x that we can have at current index. So either we could have gone two ways. Either we could have like fixed the previous index element and then derived the range for the current element, but that would have like become more messier. So instead of that, we try to reverse it. We try to like fix the element at ith index and then try to find the range possible on I minus 1 index, and then we'll be able to simply solve it. So let's see the code as well for this approach. So we initialize the dp of n cross 51, because like we need uh, nums of I can go up to 50 only. Now the base case will be dp of 0x is equals to 1. Now we start from I equals to 1 till n. We first find the prefix, so prefix of 0, and then we simply prefix of I equals to prefix of I minus 1 plus dp of I minus 1. So this is what we do. Then we we simply iterate through x, means, and the upper will be simply minimum of x comma x minus nums of I minus nums of I minus 1. And now if this upper is greater than equal to 0, means if it is not less than equal to 0, then will be no range. So this dp value will still remain 0 only. That's why we have initialized it with 0. So if this is greater than equal to 0, then the dp of ix will be simply prefix of upper. And now in the end we will iterate through dp of n minus 1 to calculate the final result, means to sum it. So the final answer will be answer plus dp of n minus 1 comma x, where x will go from 0 till nums of n minus 1. And LHF will take mod so that it does not exceed the integer values. And in the end, we'll be simply returning this answer. So this will be like, as you can see, like this is taking big of n, and this is taking big of 50. Then again, this is taking suppose big of 50 as well. So overall, like big of 100 into n. So overall, it is 2e4. Okay, 2e5. So that will be the approximate complexity of this problem, as well as the space complexity is also n into 50. So let's try to submit the code as well here and see like how much time it takes to run. This is the same code that we discussed using the 2D DP array, and it runs in 47 ms, which is very fast because of the like the lower time complexity for this solution. If we try to, instead of using this prefix sums, if we try to, means for each dp of ix, if we try to find the sum from 0 till this upper value in dp of I minus 1, then also it might get accepted, but that would means obviously not be the most optimal one. So that's why we have used prefix sums as well here. So this was the overall discussion for this approach. I hope you were able to follow along with the approach. And if you did, make sure to like as well as subscribe. And if you have yet any doubts remaining, feel free to comment down. I will be happy to help. Thank you so much for watching.